But yeah, I'm a PhD student here at Lancaster. And yeah, my PhD is focused specifically on limestone pavements. So working with Carly and also Andy, who's here and is going to talk a bit later. And yeah, today I'm going to talk about how trees on pavements, which you've already alluded to, Stephen, shape kind of communities of the limestone pavement. That's going to work. So first, I'll just go into a bit of context. So for those of you that were here at last year's conference, we talked a lot about scrub encroachment. So Carly, a few years ago, redid the Warden Evans survey, national survey, and one of the findings was that in some limestone pavements, particularly in Lancashire and Cumbria, there's been a big increase in tree cover. And where that has happened, there's also been a decrease in vascular plant species richness, which you can see in the figure on the right here. And there's a number of reasons why this might be happening. It could be due to the microclimate changing, so it becomes just too dark in the grikes. Could be leaf litter clogging up the grikes, you lose the sort of structure of the pavement. And also sometimes you get sort of bryophyte mats of certain dominant species that could inhibit plant species from coming through. So I wanted to kind of look into this possible threat to limestone pavements in more detail. So yeah, here's just a few images of kind of different kinds of pavements. Hopefully they come out all right. So this is, you get very open pavement like this. In other places you get scrubby areas, and this is kind of where possibly over time they might become a bit too dense and affect the actual community. And in other places you get really densely wooded limestone pavement. And you can see here, this is under quite a big sycamore tree, but you see that the actual physical look of the pavement changes a lot. You can see the bryophytes. You can just about see in the foreground lots of leaf litter affecting the kind of depth that you get in the grikes. So you get this kind of gradient of tree cover on many limestone pavement sites. And I wanted to look at how the community, like plant and invertebrate communities, change along this gradient. So we can kind of try and understand more about the possible effects of scrub encroachment on pavement. What will happen to plant communities and invertebrate communities if some pavements continue to increase in tree cover? So how does tree cover affect plant and invertebrate communities? Today I'm going to talk a bit about how the microclimate changes, and then the plant communities, the soil seed bank, so that's the presence of seeds in the soils at the base of grikes, which is really important when we talk about sort of re-establishment of plant communities, and also a little bit about pollinators. So last summer, so this was part of the first chapter of my PhD, I went out to 6 sites, which you can see here. So Hampsfell, Whitbarrow, Gate Barrows, which we talked about, Hutton Roof, Ingleborough and Fazer in the Dales. And I visited 40 50 by 50 meter plots throughout the summer to do some of these different methods to get data on all of these things. Each plot had a pair that was either wooded or open. So there was 20 pairs of plots. One was wooded, one was open. Initially, it was going to be just a sort of comparison of open pavement to wooded pavement. But actually, once I went out and measured things like canopy cover, I found I had quite a nice gradient from open to scrubby to wooded. So it turned into kind of that gradient that I've already talked about. So first, light. How does light affected by canopy cover? So this is a figure showing canopy cover on the x-axis and light proportion on the y-axis. So that's the amount of light that's reaching the pavement compared to the ambient conditions on the day. There's 2 lines on there. So one, the top line, which is the solid green line, is looking at the surface of the pavement, and then the dotted orange line is at a depth of 25 centimeters in the grike. So quite relatively shallow in the pavement. What you can see is that canopy cover causes light to decrease, which makes exactly what you'd expect to see. But it's quite nice to have some data here. What's, I think, interesting is looking at the difference between those 2 lines. So if you look on kind of towards the left in the more open pavements, there's a big difference in the surface and that depth of just 25 centimeters. So there's quite a range of niches available to plants in terms of light availability, which I suppose is kind of fundamental to why you get these unique communities on limestone pavements. We get woodland and grassland species in the pavement because there's a range of depths that they can grow and a range of areas where they can get different amounts of light. As you move towards sort of 50% or so, those lines start to converge, and then obviously a very high and dense canopy. There's very little light reaching both the surface and the grike. But I think what's interesting is that those lines do just converge, and so you're losing that kind of distinction in the different levels of light that you can get. So you're losing the range of niches available to plants. Temperature, I looked at temperature conditions as well. So this is compared to ambient conditions on the day again, with canopy cover on the x-axis. What this is showing is the dotted line is the ambient temperature effectively, and plus or minus that is showing whether it's a warm microclimate or a cool microclimate on the limestone pavement. You can see in the open pavement, it's above that dotted line. So generally limestone pavements are a warm microclimate because of the sort of heat radiating off the rock. And then as you get to more dense canopy, they become a cool microclimate. So again, this is exactly what I'd expected to see, and what you would expect is that as you get this increase in tree cover, you're seeing cooler microclimates, which could have effects on the plant community, but also probably really important for kind of invertebrates and pollinators, which we'll talk about a little bit later, because temperature has a big effect on many invertebrates. So yeah, the first thing to sort of note is that as we're moving from open to scrubby to wooded pavement, we're getting this cooler and darker microclimate. The next thing I just wanted to make a note of is I used some of this data, so the canopy cover, bryophyte cover, and light availability, and I put them all together into one variable, which I've called woodedness for the sake of this. I'm just sort of saying that because lots of these figures will now say woodedness at the bottom. So it's like a combined variable of all those things, and high woodedness is more wooded plots, and low woodedness is open plots. So next, plant species. I'll talk about the plant communities and how they respond to increasing woodedness. So this is a figure showing how vascular plant species richness responds to woodedness on the pavement. And you can see there's a general decrease in plant species richness, which is exactly what Carly had seen on the national survey as well. So I did also look at species diversity as well. So there was no effect of woodedness on diversity. So this negative line that we've got here wasn't the case for diversity. And I think the reasons for that is due to how those different indices treat the rare species in the community, the less abundant species. So species richness as an index is very sensitive to rare species because it treats all species as equal. So if you have a species that has one individual in a plot, that's given a species richness 1, and a species that has 100 individuals will also have add a richness of 1. So it's really sensitive to the less abundant species in the community, whereas diversity is more about the evenness between the more dominant species in the community. So it's about whether those more abundant species are kind of in similar levels to each other, whether the evenness between them is the same. So what we're seeing here is that we're losing species richness, but not diversity. So it's probably that the less abundant species are dropping out of the community, but the general kind of structure of the more dominant species is staying the same. So then go on to talk about species composition. So this kind of adds a little bit more context to what I've been saying about diversity. So this plot is an NMDS plot. So what this does is it takes my 40 plots and looks at the composition of species that I found in them and says which ones are more similar to each other or different from each other. And it plots them up here, and those that are close together are more similar. The ones that are further apart are different from each other. So you can see 6 sites are represented here. Hopefully that's made out, but there's a little bit of clustering by site. So you've got sites like Ingleborough in that bottom left corner. So those were sort of clustered together. Other sites are similarly, but generally they're all kind of overlapping a little bit, and there's some similarity in the communities that we're seeing. Then I looked at how those variables that I measured. So I measured lots of different variables that I've talked about, like woodedness, also things like elevation. So to see whether those had an effect on species composition. So the arrows on there are kind of representing the direction of that effect, but what this is showing is that woodedness is having an effect on composition. So it's demonstrating that the species composition is somewhat explained by whether a plot is wooded or not. And then you can look further and see what species are actually associated with woodedness. So these are the species that are most associated. They might not be, hopefully you can sort of read them a little bit at the back, but generally this bottom right corner, the species that are most associated with woodedness are, well, we've got holly, hazel, yew, strawberry there. So these are either tree species or like woodland species. Whereas the other way, you've got mainly open species, but also some more wooded species. So species like Dog's Mercury are also there. So kind of a more of a classic limestone pavement combination of grassland and open and woodland species. Sorry. So what this is generally saying is that woodedness on limestone pavements is causing a shift in the community, maybe from that kind of open and woodland combination to more of one that's dominated by woodland species, so tree species and more woodland flowers. And yeah, those are the kind of the key messages around the plant community, is that with this increase in tree cover, we're seeing a decrease in species richness, but I think possibly more importantly, that shift in the community. So some of those open species are probably dropping out, but they're being replaced by different species, more woodland species, more tree species. So I'll talk about the seed bank now. So the seed bank, in the context of kind of the plant community and how that's responding to woodedness, is a really important way of seeing whether, as those species maybe drop out, will they persist in the seed bank, and therefore could they come back another year and grow from seed. And in doing so, that might re-establish that community, that open community. So I took soil samples from grapes across these 40 plots, laid them on compost in the greenhouse, and spent a lot of the winter looking at emerging seedlings coming up, which is somewhat challenging depending on the species, and you get some kind of odd growth forms as well, which makes it even more difficult. But yeah, this was an interesting part of the winter. And the kind of key findings from this were that this is showing canopy cover on the x-axis, and then seed bank abundance and then richness on the left and the right. So that increase in canopy cover, increase in woodedness, caused this depletion in the seed bank. So a decrease in both the abundance and the richness in the seed bank, which is exactly what I sort of expected to see. There's a lot of literature on other habitats that have looked at this kind of gradient of encroaching scrub and found that as you get more scrub cover, you do see that depletion in the seed bank. So this was what I kind of expected to see, but good to get the data for limestone pavements. I put a couple of dotted lines on there. Those are just arbitrary lines that I've put on the figures, but showing that above sort of that 20% mark, you're seeing that kind of lower variation. So generally, above that mark, you're seeing that depletion in the seed bank. So yeah, along with that plant data that we've looked at, the soil seed bank is becoming depleted. And that's really important for kind of management, because it might be that once we lose these potential open species, they might not come back from the seed bank. So that would mean that we would need kind of a neighboring seed source to facilitate restoration of those habitats. Okay, I'll briefly talk about pollinators now. So I did just one transect in each plot throughout the year, so it's kind of an indication of what's going on with pollinators. Nothing really concrete. I'm going to do more work on pollinators this summer, so hopefully I'll have some more interesting stuff next year if we have a conference next year. But yeah, I counted the abundance of pollinators and flowers, and looked at how they responded to this woodedness gradient as well. So on the whole, there was this general weak negative effect of woodedness on overall pollinator abundance. I'm not going to go into the detail today. So there's obviously a lot of factors that affect pollinator activity, but kind of amongst all of those things in my model, there was this weak effect of woodedness. So that might be due to the microclimate, like the temperature that I talked about earlier. But I think when you look at the floral availability, it becomes a little bit more clear what's happening here. This is floral species richness and abundance. So, and that's flower abundance, sorry. So generally, there's less species and less flowers on wooded pavements compared to open pavements. So actually, what we're seeing here is probably that as you get to more wooded areas, you're seeing a decrease in flowers, and that in turn is resulting in that reduced pollinator activity that I saw. So it could be it's probably a combination of factors, but it looks like it's really driven by that floral availability. But then on the other side of this, other invertebrates, so this is just looking at pollinators, so decomposers would obviously benefit more from the wooded areas and the leaf litter that comes with that. So again, that shift in the kind of community of what we're seeing. And that picture's not very good on that lighting, sorry. So what does this kind of overall mean for limestone pavements? The key sort of message, I think, is that the open areas and the wooded areas are supporting distinct communities on the pavement. So having these areas, this is a shot of Hutton Roof, hopefully that you can kind of see there are big areas of open pavement. There's also a lot of wooded pavement underneath some of these trees, and also scrubby pavement as well. So having those kind of different habitats on the pavement gives that heterogeneity, and that overall is kind of maximizing the diversity that we see on the limestone pavement. The risk of scrub expansion, which I mentioned at the start, I think is coming in when areas like this, which again, maybe you can't see very well, there are open areas of pavement that are kind of gradually being lost to scrub and tree cover. If we lose more areas like that, those open areas, it might be that we kind of tip the balance towards wooded pavement. So instead of supporting open and wooded communities, it kind of shifts towards a more woodland dominated community. So how should we manage this? We don't know yet, which is one of the reasons I'm doing this PhD. One of the kind of key questions is how do we manage this issue of scrub encroachment? So we've set up a couple of scattered scrub removal experiments at Home Park Coriander at Gate Barrows, where we've removed scattered scrub, which is generally the management strategy, and also a dense scrub removal experiment at Hutton Roof. And these combination of experiments should give us some evidence that we can actually base decisions on and make sure we're managing the habitats in the best way. And finally, just to sort of demonstrate this experiment, this is up at Hutton Roof, dense area under sort of sycamore and hazel scrub. And over the winter, with Cumbria Wildlife Trust staff and volunteers, put in a few very, very good shifts on the pavement to coppice that hazel and that sycamore and really open out this area and a couple of other areas of pavement. And over the course of my PhD and also beyond that, we'll keep monitoring this and see how the pavement responds, whether communities come back. So yeah, that's kind of everything from me. Should we do questions now and then pass it?
Does anyone have any questions?
Yeah. Did you kind of look at the kind of limestone specialists, like limestone pavement specialists?
In terms of like plants and
plant species, I think.
Yes, I did. So yeah, I recorded all plants in all my plots. The reason they kind of don't come up on that figure, for example, is because they're not that common, so they don't generally come out in the analyses. But yeah, generally the species that did kind of respond most to woodedness were like so rigid buckler fern and limestone fern tend to favour more open pavement. They're not very shade tolerant at all. Yeah, other species didn't have kind of strong responses, but I think it's probably just due to the really low abundances that you see of them. But yeah, did include them, but I haven't looked at any specific kind of responses of purely specialist species.
Causing the increase in canopy cover over time? Is it just the lack of grazing, or is it the plant trees at the time?
Yeah, I think probably it's mainly management related. There's probably a number of other factors like climate change and nitrogen deposition as well. Kind of bigger things that are harder to detect. But yeah, management I think is probably the key driver. It's probably grazing. I don't think it'll be it's planting as much. Like, there's not huge amount of planting in limestone pavement, but yeah, you
Have you got any thoughts on the sort of temporal aspect of this? I'm just thinking with seed bank, some seeds will persist viable
Yeah.
longer during shade period. So that would help you kind of understand how quickly we need to remove scrub from pavement to maintain rich.
Yeah, it's a good point. In terms of kind of seed bank longevity, it tends to be that kind of open habitats species in those open pavements, they tend to have quite short-lived seed banks anyway. So it's probably another factor that's causing that drive is that they don't last very long in the seed bank as viable seeds. So yeah, I don't know in terms of how you'd look at kind of other ways of longevity in the seed bank, but it seems like as soon as you get sort of that 20% mark, you're just losing a lot of the seed bank abundance richness. But yeah, it's a good point.